I'm Bill Moody with Eaton Carter.
And I'm Jeff Griffith with Becker Aviation.
We're going to cover how to disassemble, inspect, and reassemble the Eaton Carter hydrant coupler. As you can see, we have several different options of hydrant couplers. On the left is our 3-inch hydrant coupler, and on the right is our 4-inch hydrant coupler. We also have different operations of the coupler. Today we're going to focus on the air reference hydrant coupler. The other types we have is a fuel reference pressure coupler. What that means is instead of air pushing the piston open in the coupler, we're going to use fuel pressure that's coming from the truck to open up the coupler. The third type we have is a digital pressure control coupler. On the digital pressure control coupler, you'll notice the difference because we won't have a port on the Venturi side. The digital pressure control coupler, we use pressure transducers on the truck to tell the system how to control pressure. And now we're going to move into the disassembly of the Eaton Carter hydrant coupler. So the hydrant coupler is two main assemblies. We have our pressure controlling elbow and our lower half. So we're going to separate these two components. To separate it, we're going to use our 1/2 wrench and start removing our nuts securing the studs. Now as you start removing the upper half and the lower half, there really is no spring tension in between the two pieces, but there will be a pressure equalization valve that will have some very small amount of tension. So now that all of my nuts are removed, I'm just going to simply remove the pressure controlling elbow from the lower half. So the first part we're going to disassemble is the pressure controlling elbow. We're going to first start by removing our reference pressure vent port and our Venturi bleed port. To remove the reference pressure port, we're going to use a 9/16 socket. You'll notice we do have a small O-ring. Inside the reference pressure, we also have a closing time adjustment screw. The closing time adjustment screw will only be there on the air reference couplers, so on this particular 64-800 coupler. On your fuel reference pressure couplers, you will not have a screw in this port. So the next thing we need to do is remove our closing speed adjustment screw. To do this, we're going to use a 1/8 Allen head wrench. And we're just going to turn it counterclockwise until that screw is loose. We're just going to tilt over the elbow and let it fall out into your palm. So what you're going to have is just a small screw and a spring. Next, we're going to remove the Venturi bleeder screw using a Phillips head screwdriver. On the bleeder screw, we also have another O-ring that we'll inspect later. Then we're going to use an adjustable wrench and remove the housing. In this housing, we're going to have two O-rings and our check. Underneath the check valve, there is going to be another spring, so we're going to tilt the control elbow over it once again and remove the spring. Next, we're going to remove our sense and reference pressure ports. This is for our Venturi sense line, and again we have O-rings on each connection. And the smaller one will be our reference pressure connection. And again, another small O-ring. So to remove the pressure equalization valve, we're going to use 11/16 crow's foot. Now we recommend using a crow's foot to remove this. If you try to use a standard 11/16 wrench, what could happen is you're going to rest on the body, which could start scratching and damaging the body where the O-ring sits. And you also could strip out the edges of the nut. So this is a pressure equalization valve. You'll notice we do have an O-ring. We can disassemble this pressure equalization valve as well by removing the nut, and we'll have one more O-ring in this assembly. So with that removed, the next thing we need to do is remove the main piston. So now we're going to remove the main piston. Before we try to remove the main piston, the first thing we need to do is make sure we have clear access to our seal retainer screws. What you want to do is look inside and get the ribs lined up so you can get clear access with a screwdriver. If the ribs are in the way, you just simply rotate the piston just slightly to give you good access. Now that I have good access, I'm going to take a large flathead screwdriver and start removing the seal retainer to remove the piston assembly.
Bill, can you remove the piston by taking that nut off?
Absolutely not. So it's a very good critical point Jeff brings up. This nut is what actually keeps this piston assembly together. Inside the piston assembly is a very heavy spring. If you were to remove this nut now, there'd be a lot of force that would actually protrude that piston up at quite a force and cause some serious bodily injury. So you definitely don't want to try to remove the piston by taking that nut off.
Okay.
So you don't need to completely remove these screws, you just want to back them up till they're all completely loose. Now to remove the main piston, what I like to use is a set of vice grips and some kind of pad. The pad is really to protect the metal from damaging the ribs on the main piston. Before we remove the main piston, one thing to note is there is a reason why we removed the bleed ports first. Behind this piston, there could be fuel trapped behind the piston. If we don't remove the bleed ports, what we're actually doing is creating a hydraulic lock behind this piston. So if you try to pull this piston, it won't allow it to pull out. That hydraulic lock will actually pull this piston back in, and you would immediately feel that force. So by removing the bleed ports, we're relieving that pressure behind the piston, so hopefully we can remove the piston a little bit easier. So if I'm going to use vice grips, obviously I don't want to clamp on the ribs extremely hard, just enough to get a good grip on the ribs. What you want to do is just slowly start rotating it. And just kind of walking the piston back and forth. Once the piston assembly is out, I can rotate the piston assembly and my 4 screws should fall out. Each screw will have an O-ring on the screw. On the main piston assembly, so when I pulled this piston assembly, you'll notice the crossover tube came out with the assembly. Depending how the piston actually is removed, sometimes that crossover tube will be inside the body. To remove the crossover tube, we're just going to lightly rotate it out, and you'll notice there's 2 small O-rings on this crossover tube. So now we have the piston assembly removed. For the purpose of this video, we're not going to disassemble this piston assembly. It can be quite a dangerous task if you're not using the appropriate tools. There is quite a heavy spring inside this piston assembly. So what we're going to do for the purpose of this video is we previously disassembled a piston assembly so we can kind of show you the length of the spring and what kind of seals are actually in this assembly. So this is a disassembled piston assembly, and this is the spring that's inside the piston. So you can see the length of this piston spring in relation to the assembly. So it's very heavily compressed. So again, if we're not using a proper vise, you can imagine the force that this piston will be released at. Inside the piston assembly, we have our main piston. We have 2 nylon lock nuts, and we have what's called our inner piston. On our piston shaft, we have a small O-ring on the inner piston side. Then inside the spring retainer, we'll actually have 6 small screws that we need to remove this retainer. We can pull our shaft out of the retainer. You'll notice inside the seal retainer is we have another Teflon seal that will have an O-ring. The most wear item in this assembly will be this Teflon seal. The shaft, as this piston operates, will be sliding through this Teflon seal. So any kind of debris, scratches, or gouges on this shaft can cut up the Teflon seal, and that's where you have bypassing into the piston. So again, for the purpose of this video, we're now going to disassemble this main piston. So with our main piston assembly removed and our crossover tube removed, the next thing we need to do is remove our seal retainer. To do that, I'm going to use my Allen wrench and remove the 4 screws that's holding the retainer in.
Bill, what's the main reason why we would have to go this far deep into the pressure control elbow and remove these seals?
So the main indicator that you would see that would tell you that you need to replace these seals is if you notice on the front side of the elbow, you'll see this small port here that actually has a screen. This is the vent for the elbow. Between the 2 areas of the inner piston, we have the 2 Teflon seals that we're about to remove. If those Teflon seals are cut, what can happen is fuel from either the inside of the piston or the back side of the piston will start exiting through this vent. So if you are in a fueling operation and we do see that fuel is constantly leaking through this vent, it gives you a very good indication that we need to dig deeper into this coupler and remove the Teflon seals.
And it would be normal just to see a little bit of fuel.
Absolutely. The normal operation of Teflon seals, as this piston moves along the Teflon seals, it's actually wiping away a very thin film of fuel from that piston. With that fuel that's being wiped away, it actually goes into that vent cavity, that atmospheric chamber cavity. Through normal operation, that fuel will build up and it will spit out just a little bit of fuel from the vent. So, during maybe a surge event or during normal operation, you might see some wetness around the vent, and that is normal. Obviously, what you don't want to see, like we said prior, was you don't want to see fuel that's constantly dripping or leaking out of this vent. And you definitely shouldn't plug this vent as well. The reason we're not plugging the vent is, again, you want to be able to have that telltale that there could be a problem that's getting ready to occur. So having a plug in here, you're really masking a problem. You're not able to see if there could be a potential failure in these seals. All right, so with my 4 screws removed, so next thing we're going to do is remove our seal retainer plate. It's actually holding in our Teflon seals. Before we remove that, there is a small O-ring that's sitting on top of the seal retainer. We need to remove that first to facilitate the removal of the seal retainer. To remove that, we're just going to use a fine pick. And again, taking extreme care not to dig into the side of the cavity. And now we can remove the seal retainer. To remove the seal retainer, I'm going to use a special pliers that has protected edges. It is acceptable to use things like picks or Allen wrenches as well. If we use something that is metal, we just want to make sure that we're not scraping the inner cavity of the coupler. The seal retainer is a very tight fit, so we are going to have to kind of walk this retainer out and start pulling up.
So there's slots in the seal retainer for those jaws to fit into?
Yes, there is. Just pull that. So you'll see the 4 holes, and that's kind of what the tool will actually go into to help facilitate pulling it up. Now in my seal retainer, we have 2 Teflon seals, one on the upper, one on the lower. And each Teflon seal has a spring energizer inside the Teflon seals. those are not removable. When you get a new kit, the seals come with a spring inside the seals. The last thing we need to remove from the inside is another O-ring. And from the inside the coupler, this is the last thing we need to remove, is our main piston Teflon seal. And just like with most of our Teflon seals, we do have a backup O-ring as well. So right now, that is the disassembly of the 64800 pressure controlling elbow. So now that we've disassembled the pressure controlling elbow, we're going to go into some key points of what you want to inspect before we go into reassembly. Jeff, would you like to cover what you would inspect?
Absolutely. First couple things that I'd like to go over is your main piston assembly itself. As you can see, the shiny surface of both the large piston and the small piston, you want to make sure that you completely dry these surfaces. And the reason being is with jet fuel being on these surfaces, it could mask some hairline scratches or scoring that has taken place on these two surfaces. With it being dry, they will reveal themselves. And if you can run your fingernail across it and catch it just a little bit, it's probably a good indication you want to replace that piston assembly or take it apart and replace just the small piston or the large piston. Some other items you want to go ahead and inspect are going to be your studs. As you can see, they are replaceable. They do have an Allen head socket on the end of them, and you would only need to really replace these if you've stripped them out or if they've got damaged or bent. Other than that, these don't need to ever be replaced. After that, you just want to check your O-rings on your pressure relief valve. Make sure everything's in good shape. Lastly, on top of your check valve, you'll see a very small hole in the top. You want to make sure that this is not plugged. Bill, do you have anything to add?
Absolutely, no, that's perfect, Jeff. So there's a few other things I just kind of want to dig in, a little bit more detail on. The first thing Jeff mentioned was the studs. So these are stainless steel studs. In the previous models, you may experience some black oxide studs. So they might obviously be darker in color. They may actually show a little bit of corrosion. There is a product bulletin you can find on Eaton Carter's webpage that explains about how to identify the black oxide studs and how to remove those and put in the stainless steel studs. Another thing to look for in the piston assembly is obviously if you're not going to disassemble the piston, it's going to be quite hard to inspect the piston shaft and the Teflon seals. If you do have it disassembled, what you really want to inspect is that shaft. If our shaft has any scratches or gouges, then obviously it's going to cut into our shaft Teflon seal. Again, the Teflon seal is what takes most of the work on this piston assembly. The other seal that we have is this O-ring at the end of the shaft. So we have two different sealing surfaces. One is at the main piston assembly, and one is on the inner piston side. So again, a nice clean shaft is imperative in this assembly. And with the check valve, as Jeff said, that orifice actually serves a pretty important purpose. What this orifice does is anytime we have a surge event, it allows pressure to come through and enter the valve quickly. As we open up the valve to start a fueling event, we want pressure to release slowly. So we don't want this piston to knock open quick and shut down quick. So during the opening operation, what happens is fuel pressure actually comes back through the check valve, through that tiny orifice. It controls a smooth open operation. So it's very imperative that we do have a good check valve in good condition and that orifice is clean and empty. So a couple other areas we want to inspect. We want to look down inside the pressure controlling elbow. We want to inspect any of the sealing surfaces. It's areas where the O-ring or Teflon seals sit inside the elbow. The surfaces where the main piston may slide against. So what we want to do is just kind of get our hand down inside as far as we can and just feel these surfaces to make sure we don't feel any scratches or gouges.
Last thing I would recommend before we finally reassemble everything is just clean our parts off really well, make sure we don't have any dirt or debris that we're going to introduce down into the cavity of the pressure control elbow.
Perfect. So really that's the main inspection areas for the pressure controlling elbow. So now we'll go into how to reassemble the pressure controlling elbow. So the first thing we want to put in is our O-ring for our seal cartridge. So the O-ring is going to sit at the bottom of the cavity.
Yep.
And now one thing you'll notice, and it's kind of hard to see, but if you look inside the cavity, you'll see this empty cavity right in the middle. You want to make sure the O-ring actually slides past that empty cavity and sits at the bottom, not inside that empty cavity. So next we're going to install our Teflon seals onto our seal cartridge. These Teflon seals go on in opposing directions. What that means is you want the spring to be visible from the outside.
And what happens if we put them on backwards?
So if you put them on backwards, what's going to happen is they're not going to seal against the piston in the correct direction. So you're probably going to have fuel bypassing through the seals, which is going to cause erratic pressure control. All right, so again, we have both of our Teflon seals in opposing directions. We're just going to slide that seal cartridge back into the cavity. And it doesn't matter what direction the holes go into because the cavity is completely open all the way around.
And that cartridge can go on in either
way.
direction as well.
Correct. Yep. I'm just going to slide that in and drop it in and kind of give it a little firm press. They're going to install our O-ring that goes on top of the seal cartridge. And just give that O-ring a good push all the way around. It can be quite a tight fit. And next we're going to install the cartridge seal retainer. Now you notice on the retainer we have a few identifying features. First we have this little notch, and then we have an offset hole. The notch is going to be pointed towards the hole that we see on the top of the coupler. The offset hole is going to go over where our crossover tube is going to go in. And next we're just going to install our securing screws for our seal retainer. And now these screws are going to go into the smaller holes on the retainer. The larger holes will be for the main piston assembly to attach to.
So our flathead screws ultimately go through all to the bottom of the housing.
Correct. So I'm just going to use a sort of a star pattern. Just check the snugness of each one more time. So next thing we're going to install is our crossover tube. So again, on our crossover tube, we'll have two small O-rings that should be replaced anytime that you remove the tube. I always like to put just a little bit of petroleum lubricant on these O-rings. Again, just a thin film just to kind of help with the installation. And the crossover tube is going to go into this offset hole. When we put the crossover tube in, we don't want to go at an angle. We want to try to go straight up and down to apply even force. If we go at an angle with that small of an O-ring, we're going to cut the O-ring, and we won't know it until we put the coupler completely back together, and we have some bypassing issues. All right, so our crossover tube is in place. Next thing we want to do is install our main piston backup O-ring and Teflon seal. So the backup O-ring and Teflon seal is going to go into this top groove. Then we're going to install our Teflon seal. And again, with this Teflon seal, it goes in one way. So the lip will be on top. It's going to go right into the same groove as a backup O-ring. And just like with any Teflon seals, we don't want to kink the Teflon seal. We want to try to keep its form. If we do have to deform it to install it, try to make a smooth bend to the Teflon. And as we install it, again, we just kind of want to run our fingers around the Teflon seals. We're checking for two things again, that we didn't nick the Teflon seal, and we also want to make sure that that backup O-ring is also seated behind that Teflon seal and it's not protruding below the seal. So next thing we're going to install is our main piston assembly. Now this main piston assembly can go in only one way. If you'll notice in the main piston assembly, you'll see a very small hole. This small hole has to line up with our crossover tube. That facilitates our pressure relief for the pressure control coupler. And it's usually best practice to have some type of flashlight or bright light above you so you can make sure that when you're going down, you don't have to twist and turn this piston. When you assemble it, you want it to go straight down. You want to do a lot of jarring movement.
And once we come in contact with that crossover tube, you can kind of feel it set in place, correct?
Correct. Yes. All right, so now the assembly is installed, I just take a quick visual look in there again with a flashlight, and I just want to make sure my holes are lined up for my screws, and I can see all the way through the crossover tube. One best practice I've done in the past, and I always recommend, is once it's in this position, take like a safety wire and just stick it through that crossover tube hole. Just make sure you can feel that safety wire going through that cavity and pull it back out. It's just a good another self-assurance to say, hey, it's in correctly and that crossover tube did not move. So next we're going to install our piston retainer screws. And again, for each screw, we do have O-rings on the screws. We want to make sure we replace those O-rings. Sometimes it could be to help facilitate setting the screws in, to use a needle nose pliers. Once the screws are in place, now we're just going to tighten the screws.
Is there a certain specification to tighten these screws, Bill?
Absolutely. So all the fasteners on the coupler will have some type of torque spec. Obviously refer to our service manual that you can find on the Eaton Carter's website. So now we're just going to tighten our piston retainer screws. And again, I kind of want to use a star type pattern. As you install these piston retainer screws, to get them started, you may need to put a little bit of pressure on the screw. Just get those threads started.
And like this assembly, if we have to, we could rotate the piston to access the screws, Bill?
Absolutely. Yeah, if our ribs are over those screw holes again, we can just rotate those ribs to gain better access. All right, now our piston assembly is inserted. Now we're going to reinstall our pressure relief valve. So again, we're going to install a new O-ring around our pressure relief valve.
And is there any adjustment to that pressure relief valve, Bill?
No, there's not. With the pressure relief valve, you're just going to tighten it all the way down until it's snug. And again, there are torque specs within the service manual. Once our pressure relief valve is installed, next we're going to flip the coupler over and start reinstalling our check valve and closing speed adjustment screw. So with our check valve, the first thing we're going to do is install our spring. Just going to drop it into cavity. We're going to take our check valve, again put a new O-ring on our check valve and install that until the spring. And then install our check valve retainer. And again, we're just going to tighten it till it's snug. Next, we're going to install our bleeder screw. And again, we're going to replace our O-ring on our bleeder screw. And using a Phillips head, we're going to tighten the bleeder screw down. And once again, just snug. If you tighten these screws down too far, what's going to happen is you're actually going to cut that O-ring, and you'll have fuel that leaks out while you're flowing. Next, we want to install our closing time adjustment screw. So once again, on air-controlled hydrant couplers, you will have a closing speed adjustment screw. This screw dictates how quickly the air escapes from the piston for the closing time. So the initial adjustment on these closing speed screws is you tighten the screw all the way down and you back it out 3 turns. That should give you a closing time of the hydrant coupler about 2.5 to 3 seconds. If you are using a fuel reference pressure hydrant coupler, you will not have this screw. Yep. The closing time on a fuel reference hydrant coupler is dictated by the truck. So we're just going to install the spring and the screw and take our Allen wrench. We're going to back that screw all the way down just until we feel it's snug. We're going to back it out 3 turns. 1, 2, 3. And that'll be our initial adjustment. Once we have the closing time screw adjusted, we're going to insert our plug, and again, replacing the O-ring on the plug. And using our thin-walled 9/16 socket, we'll tighten that plug, and again, just snug. Next, we're going to reinstall the reference pressure line connections.
Are those special fittings, Bill, or can I just use any fitting out of my nut and bolt bin?
It's a good question, Jeff. So these are JIC fittings. What you don't want to use is a standard MPT fitting. If you use a standard MPT fitting, you could actually strip out the holes. So we definitely recommend using a Carter-approved JIC fitting. And again, they do have O-rings, so we do not want to over-tighten these. We just want to install these until they're nice and snug. And that is the complete reassembly of the pressure controlling elbow. Next, we're going to move into disassembly of the lower half. So now we're going to disassemble the lower half. The first part we're going to remove is our poppet. To gain access to the poppet, we need to operate the handle to open the valve. To do this, we're going to push our detent pin. We're going to rotate our operating handle. To gain access to our poppet. Once the poppet is open, we're going to take our Phillips head screwdriver and remove our 4 screws. Once my 4 screws are removed, I'm going to slide the poppet off the linkage. Underneath the poppet, we have an O-ring, so we're just going to go ahead and remove this O-ring. And then we're going to remove our nose seal. To remove the nose seal, you just want to apply even pressure to opposite sides of the nose seal and just start working it up. On our nose seal, we have a quad ring and a backup ring. We're going to utilize a small screwdriver and remove our backup ring by finding the tab. We're just going to push that on the tab. And start walking the backup ring off of the nose seal assembly. Once the backup ring is removed, we can now remove our quad seal. So there can be situations where you cannot pull the nose seal out by your hands as I did. In those situations, you can use other tools, something such as like a plastic crow's foot to get in there to kind of help wedge the nose seal out of place. The one thing we try not to use is any type of metal tools, such as screwdrivers or picks. we really don't want to scratch the inside surface of this collar. Now in the special situation where you just cannot get this nose seal out, you may have to actually disassemble the lower half from the pressure controlling elbow to gain access to the top side of the nose seal to pop it out of the hydrant coupler. So then we remove our wave spring.
So what you're saying, Bill, is up to this point, if we just had a problem with our nose seal, we could change this in the field without removing the whole lower half.
Correct, Jeff. So if we are doing a quick inspection, we have a situation where the coupler is leaking while it's connected to the hydrant valve. Remove the coupler, we do see a lot of heavy scoring, nicks, and scratches on the nose seal. We can just open the poppet in the field, remove the nose seal, install a new nose seal and quad seal, and be back in business. All right, so with our nose seal removed, we're going to flip the coupler back over. We're going to close it. And now we're going to remove operating handle. To remove the operating handle, we're going to use the 7/16. We're going to remove our operating handle from the crankshaft. We're going to remove our Woodruff key. And then we can start removing our linkage and cam. To remove the cam, the first thing we need to do is remove the cotter pin. Now you'll notice this cotter pin looks a little different than the rest of the cotter pins. It is a flathead cotter pin. The reason why this is flat is our pressure relief device from a hydrant coupler actually rests on this linkage assembly. If we use a standard cotter pin, that cotter pin could interfere with our pressure relief device. So we got to make sure we're using the proper cotter pin in this location. So I'm going to use a screwdriver and start bending cotter pin. I'll take my needle nose pliers and start squeezing them together. I'm going to use my screwdriver again, just start pulling the cotter out just enough so I can get a pair of pliers on it. As I remove the cotter pin, there will be a washer just underneath the cotter pin. The next thing I want to do is I want to remove the bushing that's inside the cam. To gain access to the bushing, you just kind of want to wiggle the cam around a little bit, get the bushing to push out. And there's our bushing for the cam and the crankshaft. And now if you have a coupler that's been out there in use for quite a while, and maybe it hasn't been rebuilt in a while, this bushing could be worn down to where you're not able to remove this bushing. In that situation, you may have to just leave the bushing in and clock the cam off as we're getting ready to do. So once our bushing is removed, I'm just going to grab our cam, rotate the handle over, allow the cam to slide down into the body. Once it's slid into the body, I'm just going to re-rotate my crankshaft over, turn the lower half over. The linkage is going to be held on to the cam by a floating pin. We'll pull the linkage out, allow that floating pin to drop. I'm going to pull my linkage. rotate the lower half again. Then I can pull out my cam. Once the cam is removed, now we can remove our crankshaft. So next we're going to remove the crankshaft from the body. To remove the crankshaft, you're going to notice inside the body we have this cavity. That cavity is going to help facilitate the removal of the crankshaft. So we're going to slide the crankshaft into the body. As we slide it, we kind of want to push the bearing and the washer in the opposite direction. And then we can remove our crankshaft. On our crankshaft, we have our bearing with the flange, and our washer. Then inside the body, we have a washer, an O-ring, and another washer. And then we have a flat bearing. So if I were to look at how this is assembled on the crankshaft, we're going to have our metal washer, our bearing with the flange, our flush bearing, then washer, O-ring, and washer. Now we're going to remove our detent pin. To remove the detent pin, I'm going to use a 3/8 wrench and either a small screwdriver or a pick. What I want to do is get inside this detent pin where the hole is and just put my screwdriver or my pick into the hole. I want to push the detent pin to gain access to the top of the pin. Using a 3/8 wrench, I'm going to loosen my detent pin bolt. I'll push the detent pin through. The coupler. You'll notice the detent pin does come out with a spring. Inside this hole, we are going to have a small ball bearing. To remove the ball bearing, just as I did, we're going to kind of just wiggle around the outer coupler until that ball bearing drops into that cavity, and then we just tip it over and allow it to drop into your hand. Next, we're going to remove the outer collar from the body. To do this, we need to remove this retainer clip. To do that, I'm just going to use my small screwdriver. We're going to grab the tab on the retainer clip. Just bring it out slightly. And I'm just going to start rotating it around the collar. I'm then going to tilt the coupler back over, lightly drop the body, and I'm just going to slide the outer collar over the body. The next thing we need to do is remove our lugs. These are the lugs that attach to the API ring on the hydrant coupler. Each lug is attached by a wire ring. Each wire ring has a set of 4 lugs. To remove it, you just pull out on the lugs. And then you'll continue around the body and remove all of the lugs. At this time, this concludes the disassembly of the lower half. So now we're going to go into an inspection on key points of components within the lower half. Jeff, what are some of the things you would inspect while you have this lower half disassembled?
First thing I'm going to take a look at is the poppet. This beveled edge here, I want to make sure that there's no gouges, scrapes, scratches in it, because this is going to be the sealing surface to our nose seal when we're in the closed position. If we have any metal removed here, we're going to potentially have a leak. Some other items we're going to take a look at are all the sealing surfaces, such as where the crankshaft rides, to make sure that those surfaces are smooth as well. there's any cuts, scrapes, or gouges, we may need to take just a little bit of emery cloth if we can to smooth those out. But if they're deep cuts and gouges, you may have to go ahead and replace your body at that time. Another key area to look at is your open-close handle. Mainly you want to check the end here for wear. If you see excessive wear, you do definitely want to change this handle out. The last item you want to take a look at is the bearing. This is the bearing that goes between the crankshaft and the cam. This bearing can get wore out, and if it is, it could potentially have metal-to-metal contact between the crankshaft and the cam. And you'll notice this with the opening closing handle being a little loose and a little sloppy.
Okay.
Those are the key components I would take a look at, Bill.
Perfect. Thank you, Jeff. Just some other things I would look at as well is we want to do a quick visual inspection of our outer collar. The first thing I'm going to look for is this edge here. This is the edge that's going to probably get the most wear, as it's the edge that's always being dropped into the hydrant valve. What can happen is, after time of use, this can become mushroomed. If these areas are mushroomed, what can happen is if we try to reinstall it onto the body, you won't be able to get it to reinstall. So what we can do is we can take a hand file and just lightly file it down to kind of get that natural curve again, so we can easily install that outer collar. Some of the other areas I'm going to inspect is, really taking a very close look at any type of hairline fractures that you might see in the outer collar. These outer collars, after they're used for quite a while, and they're getting a lot of use of sliding and being, set onto the hydrant valve, they can become out of round. If they become out of round, you will start to see the hairline cracks. You might not be able to visually see that it's out of round. So the hairline cracks will give you a good early indication. Some other things to check is the crankshaft. So again, the crankshaft uses these Teflon seals to help with that rotational movement so we don't have metal on metal. We want to check the surfaces of the crankshaft just to make sure that it is a good smooth surface. We don't have any scratches or gouges in the crankshaft. Another area to inspect is our detent pin. These detent pins are fairly open to the environment. It's on the underside of the hydrant coupler, so it gets a lot of dirt and debris that can get up inside the detent pin. So what I want to do is just remove the spring, just check the surfaces. If we feel a lot of pitting, corrosion, we can take a fine emery cloth and try to smooth that back out. That way we have a smooth operation of the detent pin when we reinstall it. One other area to inspect are our lugs. Again, these lugs are what keep the hydrant coupler attached to the API ring. When we go through our testing, we will show how to use a wear tool to check the tolerances on the lugs. But before I install them, obviously I just want to visually check the lugs to make sure that they are not mushroomed, that they are in good condition. And I think that completes the inspection of the lower half. Do you have anything else to add, Jeff?
Just when you're ready to reassemble everything, you want to just make sure that you clean everything really good and get all dirt, debris off all these items before we reinstall them.
Okay. Thank you, Jeff. So now that we've performed our inspection, now we're going to reassemble the lower half. The first step in reassembly is we want to reinsert our lugs. So our lugs are going to be reinserted with the fat part of the lug facing down and our skinny part facing up, with it pointed outwards from the body. The lugs are going to be set inside the notches. So what you want to do is just line up each lug to their notch. And you want to press in the lug guide wire to make sure it's flush on all sides. Once we have our lugs reinstalled, we want to grasp the lugs with our hands, and we're going to gently flip the body over as not to remove any of the lugs. And then we're just going to flip our lugs down. This is going to help facilitate reinstalling the body into our outer collar. We're going to make sure our lug wire races are all even and pushed in. We're then going to take our outer collar and flip it over. Next, we're going to gently install our body into the outer collar. So I'm going to slide the body into the outer collar and then gently pull up on the outer collar. Next, I'm going to go ahead and install a retaining ring. We're going to make sure my retaining ring is set firmly into the groove, and then I can release the outer collar. Now we're going to go ahead and install our detent ball and pin. To install the detent ball, we're going to put the detent pin hole on the bottom side. I'm going to place my finger on the back side of the detent pin hole. And that's just to catch the ball in case the ball tries to go completely through. Now I'm going to push my detent ball into the hole. You just kind of want to slide the coupler back and forth until that ball has set. You can tell the ball is set if you shine a flashlight through the hole, and you can see that the ball has dropped into its hole. Then I'm going to install my detent pin and spring. I'm going to push up on the detent pin and at the same time install my detent pin bolt. Then again with my 3/8 and my pick, I'm going to insert my pick into the detent pin. Push the detent pin once again so I can start to tighten my detent pin bolt. With my detent pin installed, obviously I want to do a quick functional check just to make sure I installed it correctly and I can push it and it retracts back. Next, we're going to install our crankshaft. Before I install the crankshaft, I'm going to go ahead and take my cam and insert it into the body. Now the cam, you have two holes. The top hole, the bigger hole, is going to go on top, and the little curved edge is going to go towards the outer part of the body. If we look inside the body, you'll see that one side has a notch that goes farther down. So the curved side of the cam is going to go into that notch, and we're just going to let it set there. So we're going to slide the crankshaft into place. Once the crankshaft is in place, now we're going to flip the coupler back over and install our poppet. So to install the poppet, we just want to pull down on the cam, take our linkage and slide it over the cam. They're going to insert our floating pin. Once the pin is inserted, you just want to slide the linkage and the cam back through the cavity. And that cavity is what's going to keep that pin in place.
So we don't have to worry about that pin ever falling out?
Correct. Yep. All right, so now with our poppet installed, we're going to pull up on our cam, and we're going to attach the cam to the crankshaft. We're going to rotate the crankshaft, rotate the cam. Then we're going to take our bushing and install it onto the crankshaft. Next, we're going to install our cotter pin. So Jeff, do we want to reuse our used cotter pin?
No, we never want to reuse cotter pins because once we bend the legs, the cotter pins get weak and have a potential to break.
Okay, thank you. All right, so I'm going to take a new flathead cotter pin, insert my washer. We want the bevel edged to go against the flat edge of the cotter pin. We're going to insert the cotter pin into our crankshaft. Make sure it's seated well. Then we're going to bend over our legs on the cotter pin. Once we have the legs bent over, I just want to do a quick functional check to make sure everything moves and pivots well and the cotter pin is not dragging on the body. Next, we're going to go ahead and reinstall our operating handle. We're going to take our last washer, install it into the crankshaft. We're going to rotate the operating handle to the closed position. Lay the lower half on its side and insert woodruff key. And we'll take our operating handle in the closed position and slide it onto our woodruff key. Once the handle is in place, we're just going to squeeze it until it's set. Then we're going to insert our large flat washer, a lock washer, and our operating handle bolt. We're going to use a 7/16 wrench to tighten the operating handle bolt. And now we're going to reinstall our nose seal. To reinstall the nose seal, we need to open our lower half back up. So again, we're going to push our detent pin, pull up on the outer collar, rotate the operating handle to the open position. This will give us access to the linkage to be able to install the poppet. The first item to install is our wave spring. We're going to drop the wave spring just down inside the cavity. Next, we're going to reassemble our nose seal. For the nose seal, we're just going to slide our quad ring onto the nose seal until it's set up against the lip. And then we're going to reinstall our backup ring for the quad ring. To do this, we're just going to take one tab, slide it into the retaining ring groove, and just start walking around the nose seal. And we're just going to make sure the quad ring and the retaining ring is set. Next, we're just going to firmly push down the nose seal into the body. We want to apply even force on both sides. We want to get the nose seal set as well as you can, because remember, once we operate the operating handle to close it, it's going to help seat that nose seal into position as well. And lastly, we're going to install our poppet O-ring into the linkage groove. Install our poppet. We want to make sure our holes are aligned with our screw holes in the linkage. And again, with even force, push down on the poppet until it pops into place. And now we're just going to take our poppet screws with the Phillips head screwdriver and reattach the screws. I'm just going to go back through and kind of tighten them in a star pattern until they're snug. Once we have our poppet installed, we can now turn the lower half over, move my operating handle to the closed position, drop the body down, and that completes the reassembly of the lower half. Now that we've reassembled the lower half, we're going to reattach our pressure controlling elbow to our lower half. Before we do that, we need to reinstall our flange O-ring. And then we're going to set our pressure controlling elbow on our lower half. Now the elbow does have to go in a certain orientation. You want the inlet, so the open side of the coupler, facing away from the operating handle. When we install the pressure controlling elbow onto the lower half, we want to try to do it as level as possible. Next, we're going to install our dust cover onto one of the studs using our stud washer and nut. So we're going to attach the lanyard to one of these studs, our lock washer, then our stud nut. We're going to go ahead and install another stud nut and washer to the other side. And now that we have two stud nuts and washers installed, we're going to apply a little bit of force to the pressure controlling elbow to make sure it's seated against the lower half. And let's go ahead and just snug up our stud nuts. And with those two stud nuts snug, we now are confident that the pressure control elbow will be flush with the lower half. What you don't want to do is install all the stud nuts and tighten them on one side and then go to the other side. What can happen is the upper half could separate from the lower half because we're going to either pinch the O-ring and it's just going to have a small separation. So what we're going to do now is we're going to install the rest of our stud nuts and washers, and we're going to tighten them in a star pattern. And that completes the reassembly of the Eaton Carter hydrant coupler. So next we're going to go over a critical check for the lower half of the hydrant coupler. Per the EI 1584, 4th edition, we have to do checks on these lugs to make sure the lugs are in good condition, and check the coupler as well to make sure when the coupler is on the API ring of the hydrant valve, that it's not going to inadvertently separate while we're refueling. We do have a tool to perform this test. This is the Carter 61362 hydrant coupler tester, wear gauge. We have two different components to the wear gauge. The first part is going to check the mating surface of the lower half. So to use the hydrant coupler wear tool, we first want to set the wear tool. The pins will go towards the coupler. We want to push on that detent pin and pop our lower half out. With it out, you're going to notice that I can see all four pins raising above the surface of the wear gauge. This is the condition we want to see. This is showing that we have a good coupler. We want to see all four pins raised. If at any time we see one pin that is below the surface of the wear gauge, that tells us we either have some worn lugs or we have a worn collar or body. The next thing I want to do is, while the gauge is installed, I actually want to kind of rotate the collar. And I want to watch those pins to make sure the pins don't start lowering in certain spots. So in other words, I want to check this thing, in a 360 manner. All right, so as you can see, right now we have a good coupler. The next thing we want to check is actually our lugs. So we're going to remove the wear gauge. Next thing we want to do is we actually want to check the thickness of our lugs. So again, we're going to reactivate the lower half by pushing our detent pin. Our lugs are now exposed, so we're going to take our lug tool. We're going to set it on top of the lug. And we're going to rock it back and forth. If both edges of the lugs are flush on the collar, that's showing we have a worn lug. If I'm able to rock the lug, that's showing we have good lugs. So we still have the thickness that we need to attach. The other thing we want to do is, even though it passed our wear tool, we also just want to give a good, quick visual indication of the lugs and of the notches that the lugs are sitting in as well. Just make sure everything's in good condition before we put this coupler back in operation. Once we completed our test, we're satisfied that it's passed the required wear test. Just deactivate the lower half, and that completes the wear check of the hydrant coupler.